Yeah, good afternoon, guys. Good afternoon for
Good
17th class.
afternoon, sir.
Good afternoon. So today, I think the weather is somewhat cool. No sun. It's raining here at my place. Hope today evening will be cool place. Okay, so today we are in the lecture 17 of Unit 2. So in the last class, we have started Unit 2. So today is the second class. So we will discuss some of the topics related to the fluid flows. What is a fluid flow? What are the classifications of fluid flows? Right? So waiting for some more students. Okay, we'll start slowly. So in the last class, I have discussed about the introduction of fluid kinematics, the definitions of fluid kinematics, statics, fluid mechanics, how the fluid concept goes, right? So these are the unit 2 topics. So in this unit 2 also, you are having 70, 80% problems only. So if you get a question in exam, so if you see this one, if you see the unit 2, so you may get what are the classification of flows, explain any one, or they will ask write short notes on steady flow and unsteady flow, or laminar flow, turbulent flow with examples. So like this, you will get questions in the theory part. And if you see equity of equation of continuity for three-dimensional laws or one dimension, there is a derivation part. So they will ask for derivation. They will ask the derivation of continuity equation, how it is derived. Derive the continuity equation like that. And the questions like short questions in the 2 marks or 3 marks questions, you will get what it defines surface body forces, right? And also what are the forces acting on the pipe when it is stressed. And coming to the derivation part, you will get derive Euler's or Bernoulli's equation along the streamline, or derive the continuity equation. Maximum you will get 3 derivations for exam. One is continuity equation derivation, Euler's derivation, Bernoulli's equations. And apart from that, majority you will get 8 marks or 7 marks problems based on the one dimension, two dimensional laws. Based upon the continuity equation, you are having number of problems that we will discuss in this unit. And also based upon Euler's and Bernoulli's equation formulas also, you are having the problems, and the forces, pipe bending forces also, you are having the problems. So majority in this session, in this unit, you are getting 70% problems, 30% theoretical. So everything we will discuss in this class, don't worry. So only the thing is, after the units or after the whenever you find free time, not only in my FM subject, other subjects what you are getting problems. So take a book or take a rough papers, keep on practicing. That's it. That is the only thing you have to do is keep on practicing. Keep any songs in your ear with earphones. Keep on practicing the problems. Automatically, you will practice the problems and you can know how to solve the problems. Right? So we'll go in deeper. Now we'll discuss what are the fluid flows. What are the methods of fluid flows based upon two scientists. So the two scientists, Lagrangian and the Eulerian, have gave some approach based upon the fluids which are in motion. Individual particles in the fluid move at different velocities. So if you take a bucket of water, in that bucket of water, you are having many small liquid individual particles which are moving at some velocities. So it depends upon the flow of direction. For example, if you are making a whirlpool, so మీరు bucket water తీసుకొని చేత్తో బాగా టర్నింగ్ చేశారనుకోండి, you will get some whirlpool, turbulence. So then the water flow particles, the particles are moving circularly with different velocities. Like that. Moreover, at different instants, fluid particles change their positions based upon the external pressure what we are giving, right? In order to analyze the flow behavior, in order to analyze the flow behavior, in order to analyze the flow behavior, flow behavior, the function, space and time, we follow one of the following approaches. So to analyze the flows of fluid, we follow some of the two principles, any of the two principles. First one is Lagrangian approach, second one is a Eulerian approach, right? Yeah. So if you see a water in a pipe, see this figure, water is flowing in a pipe with constant velocity. So in the water, you cannot see physically, but I said starting of the class, fluid kinematics is completely imaginary concept. So here this one is Ramesh, don't talk. Here you can see a three-dimensional liquid solid as a liquid particle is moving with constant flow, right? Here in this approach, the fluid particles of the fixed mass is selected. We follow the fluid particle during the course of motion with time. The fluid particles may change their shape, size, and state as they move. So whenever the particles are moving from one place to another place, they can change their shape, size, and state as the mass of fluid particles remains constant. So here the mass of the fluid remains constant, but you will get the changes in size, shape, and state. The basic laws of mechanics can be applied to them all the times, right? The task of following a large number of fluid particles is quite difficult to analyze. Therefore, this approach is limited to some special applications, right? So this Lagrangian method is applied only for some specialized cases only, but commercially we are using Eulerian concept of methods, right? Applications, for example, re-entry of spaceship into the Earth's atmosphere and flow measurement system based upon the particle imaginary. So now if you see the Eulerian approach, so last class slide work chepkunnam, this slide work we have discussed. Now we are coming to the real actual class. So I think total 1, 2, 3, 4 students were in the line. In the case of Eulerian approach, the velocity, మనం first unit లో చెప్పుకున్న the properties, the velocity, the acceleration, the pressure, the density are described at the point in the fluid flow. So whenever the fluid is flowing in a container or a pipe, at any point, the velocity, acceleration, pressure, density are considered. This method is commonly used in fluid mechanics. So this method, Eulerian method, is commonly used in the fluid mechanics because of these are described. What are described? The velocity, the acceleration, pressure, and density are described. Then, if you see the advantages of Lagrangian rule, since motion and trajectory means the path how the water is flowing. Since the motion means the nature of flow. The trajectory means how it is flowing, depends upon the pipe manaki ila undanukondi. So pipe is in a bend shape, the water is also will go in a bend shape only. The pipe is in a bend shape, the water is also goes in a bend shape. Of each fluid particle is known as its history can be traced. Since the particles are identified at the start and ending, the conservation of mass is inherent. Disadvantages. The solution of the equations present appreciable mathematical difficulties. Expert. Certain special cases, therefore, this method is rarely suitable for practical applications. These are used only for particular things only, not for all general things. Why? Because here we are having the certain problems. Which that's why we are using Eulerian approach, where the velocity, acceleration, pressure, density are described for the analysis of the fluid flow. Okay, next. If you see the analysis, Lagrangian analysis describes as a defined position, velocity. Yeah, sorry for some technical issues in the internet. Okay, so it's in the line. Okay, so here they define that is the position, velocity, acceleration, pressure, temperature, etc. as functions of time. These are based on the functions of the time. The track, the location of migrant, Therefore, if you see the example of Lagrangian equation, track the location of migrating bird. Migrating bird ante enti, whenever a bird is migrating from one place to other place. Why it is migrating? Because of hibernation. అంటే పిల్లలు పెట్టడానికి ఫ్యామిలీ their evolution పెంచుకోవడానికి ఫ్యామిలీ సంతతి పెంచుకోవడానికి these birds, some birds will move from one place to other places. So దీన్ని ట్రాక్ చేయాలంటే we can use this Lagrangian approach, which is very rarely used. If you take the Eulerian concept, it describes the flow. It describes the defined position or velocity or acceleration, but it describes the flow with respect to velocity, acceleration, pressure, temperature, etc. as functions to position and the time. Example, counting the birds passing a particular location. So counting the birds passing the particular location. If you see the birds are flying in the sky from east to west or from west to east. So whenever you are having a group of birds, a bunch of birds flying in the sky, whenever you are counting which are moving in a particular location, there you can apply the Eulerian concept of approach, right? Next, the law of physics in their simplest forms describe the systems. The law of physics in their simplest forms can describe the system, that is Lagrangian approach. Conservation of mass, momentum, and equal energy. Conservation of mass ante either the mass may be created nor destroyed. That is a conservation of mass like that. It is impossible to keep the track of the system in many fluid problems. So example ఇందాక మనం తీసుకున్నట్టు బర్డ్స్ ట్రాక్ చేయడం, బట్ if you take the fluids, water ni తీసుకున్నప్పుడు motion లో, it is very impossible to track the system in many fluid problems. That's why the Lagrangian approach is maximum not practical for fluid problems, right? The law of physics must still hold in the Eulerian world. We need some tools to bridge the gap. So whatever the problems you are facing for this Lagrangian approach, so there must be some tools. There must be some advanced tools, advanced other systems in order to solve the fluid mechanics problems, right? Next, classification of fluid flows. Classification of fluid flows. So generally in the nature, we are having six types of classification of flows. So we will discuss each one by one. The first one is steady and unsteady flows. Steady and unsteady. నిలకడగా ఉండడం, నిలకడగా లేకపోవడం, right? Next, uniform and non-uniform flows. Uniform is going in one fashion. So uniformly they are going. Uniformly, for example, these three things are going, these three lines are going uniformly means till the end of the exit. So it should go in this manner only. ఇది మళ్ళీ ముందుకు రాకూడదు, ఇది వెనక్కి రాకూడదు. That is nothing but the uniform and non-uniform flow. Next one is laminar and turbulent flow. Laminar means normally going in a one direction. Turbulence means it is going in a turbulent wave, depends upon the obstacles coming in front of the fluid. Compressible and incompressible fluids. If you take the hydraulics, compressible and incompressible. Hydraulics means the fluids which we are using in the machinery. These comes under compressible and incompressible hydraulic fluid flows. Next, rotational and irrotational. Rotational, irrotational, which cannot be rotated. One dimensional, two dimensional, and three dimensional flows. One dimensional means only x-axis. Two dimensional means x and y-axis. Three dimensional means x-axis, y-axis, and z-axis. So these are the six flows. If you get a question in a unit 2, they will ask, classify the different types of fluid flows, explain any one with example or sketch. Appudu meeru any one you can choose and draw the figure. If you see the example for the steady flow at constant rate through the duct of uniform cross section, the region close to the walls of the duct is disregarded. So if you see, the duct means just only it is a place where you are using in between the piping channels, right? Duct like this. Okay, that is the example of steady flow. Steady non-uniform flow means flow at constant rate through a duct of non-uniform cross section, tapering pipe. So if you you take a taper pipe, taper means oka side down ఉంటుంది, oka side narrow ఉంటుంది. So this is a taper pipe, right? Next, unsteady uniform flow at varying rates through a long straight pipe of uniform cross section. Non-uniform flow ki, where we are using a duct of non-uniform cross section, which is again tapered, right? Now we'll discuss each things one by one. Okay, right. The first one is steady flow. It is a flow in which the fluid characters like velocity, prati flow you are having velocity, pressure and density. ఇది మీరు by heart చేసుకోండి. velocity of fluid, pressure of a fluid, density of a fluid, right? It's a type of flow in which the fluid characteristics like velocity, pressure and density etc. at one point do not change with the time. So time to change గా ఉన్నటువంటి fluid characteristics like velocity, pressure and density is called as steady flow. అర్థమైందా? Time తో change కానటువంటి, right? At a point does not change with the time. Those are called steady flow. However, these characteristics may be different at different points in the fluid flow. So what it is saying? However, these characteristics may be different at different points అంటున్నారు, right? Whenever the fluid is flowing in a open drain or in a pipe, depends upon the obstacles or depends upon the curves, bends or ups and downs, automatically the pressure changes, automatically the speed also changes, thereby the characteristics also changes from one point to other point, but they does not change with respect to the time. Then mathematically దీన్ని మనం ఎలా ఎక్స్ప్రెస్ చేస్తున్నాం? velocity by dt, dou v by dt, x0, y0 and z0, that is equals to 0 at x-axis, y-axis and z-axis equal to 0. Why? Because it is not changing with the time, right? Dou p by dou t with respect to t, it is also 0. Dou rho by dou t is equals to 0, so it does not changing with time. These are the mathematical equations for the steady flow. You have to just by heart these things. ఏం లేదు ఇక్కడ, velocity, pressure, density. So velocity by t, pressure by t, density by t is equals to 0 అని simple గా, where x, y, z is a fixed point in a fluid field. So ఇక్కడ మనము ఇది ఒక fluid field అనుకుంటే, see here, if you are considering this is a fluid flow, this is a fluid particle, this is a x-axis, this one is a y-axis, this one is a z-axis, right? So here this fluid particle is having x, y and z-axis. So the fluid flow is stating the type of flow where the fluid characteristics like velocity, pressure and density at a point does not change with the time. Time to change కానటువంటి three characteristics అయితే ఏదైతే ఉందో we are calling them as a steady flow. Okay. Example, the flow of water in a pipeline due to the centrifugal pump being run at uniform rotational speed. అంటే ఒక సెంట్రిఫ్యూగల్ పంప్ ఉంది, ఈ సెంట్రిఫ్యూగల్ పంప్ ద్వారా వాటర్ బయటకు వెళ్తుంది, దేనిలోంచి? పైప్ లో నుంచి. సో ఇట్ ఈస్ రన్నింగ్ అట్ యూనిఫామ్ రొటేషనల్ స్పీడ్. సో సెంట్రిఫ్యూగల్ పంప్ రొటేషనల్ గా ఉంటుంది, యూనిఫామ్ గా రొటేషనల్ గా ఉంటుంది. దట్స్ వై ద ఫ్లో ఆఫ్ వాటర్ ఇన్ పైప్ ఈస్ స్టడీ ఫ్లో. స్టడీగా ఉంటుంది కాబట్టి స్టడీ ఫ్లో. నెక్స్ట్, అన్స్టడీ ఫ్లో. It is a type of flow in which any one or all fluid characteristics like velocity, pressure or density at a point change with respect to time. Simple ga steady flow ante does not change, unsteady flow ante it will change with respect to time, is called unsteady flow. Mathematically, dv by dou v by dou t is not equal to 0, dou p by dou t is not equal to 0, dou rho by dou t is not equal to 0. దాన్ని మనం ఏమంటున్నాం? అన్స్టడీ ఫ్లో అని సింపుల్ గా చెప్తున్నాము. Then what is the example here? Liquid falling under gravity. Liquid falling under gravity out of an opening in a bottom of the vessel. So పై నుంచి మనం నీళ్లు పోస్తున్నప్పుడు liquid is falling under gravity out of an opening in a bottom of a vessel ఉంది, రైట్? ఈ వెజల్ లో హోల్ ఉంది, ఇక్కడ ఈ హోల్ నుంచి వాటర్ కింద పడుతుంది. సో దిస్ ఎగ్జాంపుల్ ఇస్ నథింగ్ బట్ అన్స్టడీ ఫ్లో. సో ఇర్రెస్పెక్టివ్ టు టైమ్ ఇట్ విల్ చేంజ్. అదే ఇక్కడ దీనిలో ఏం జరిగింది, ఒక సెంట్రిఫ్యూగల్ పంప్తో వాటర్ని మనము పుష్ చేస్తున్నప్పుడు వాటర్ అనేది ఇట్ విల్ గో ఇన్ స్టడీ ఫ్లో. దట్ ఈస్ ఎగ్జాంపుల్ ఆఫ్ ద స్టడీ ఫ్లో. సో ఇక్కడ ఏం జరిగింది, దిస్ ఆర్ ఈక్వల్ టు జీరో, దిస్ ఆర్ నాట్ ఈక్వల్ టు జీరో. సింపుల్గా ఎగ్జామ్లో వస్తే ఇట్లా రాసేసేయండి, నో ఇష్యూస్. నెక్స్ట్ సెకండ్ వన్, యూనిఫామ్ ఫ్లో అండ్ నాన్ యూనిఫామ్ ఫ్లో. Second category is uniform and non-uniform flow. It is a type of flow in which the velocity at a given time does not change with respect to the space. That is the length or direction. Is called as uniform flow. So ఈ అన్నిటికి డెరివేషన్స్ అయిపోయినాయి కాబట్టి just we are seeing the last point. Then the mathematically dou u dou v by dou s with respect to t is equals to constant is equal to 0, right? With a given time does not change with respect to space and the length or direction of the flow. The length of the flow ఎంత ఉంది, the direction of the flow ఎటు వెళ్తుంది, దీన్ని కన్సిడర్ చేసుకొని with respect to time does not change with respect to time is known as uniform flow. Example, dou v by dou s to the t is equals to constant is equal to 0, where is dou v is equals to change in the velocity, dou s is equals to displacement in any direction. మనం ఇక్కడ ఎల్ పెట్టుకున్నాం అనుకోండి, డిస్ప్లేస్మెంట్ ఇన్ ఎనీ లెంత్ అని చెప్పుకోవచ్చు. ఓకేనా? ఎగ్జాంపుల్, ఫ్లో త్రూ ఏ స్ట్రైట్ పైప్ ఆఫ్ కాన్స్టెంట్ డయామీటర్. అంటే డయామీటర్ ఉందనుకోండి, సేమ్ డయామీటర్ 20 mm డయామీటర్ పైప్, ఎంత, ఒక 5 meters పైప్ ఉందనుకోండి, 20 mm డయామీటర్ పైప్. Whenever the water is flowing continuously, we will say it is a uniform flow. Next, see the figure here. It is a pipe. This one pipe anamata. Ee pipe lopala water is going uniformly. How ela cheppochu? It is a type of flow in which the velocity at any given time does not change with the time. With respect to the length or direction. So ఈ లెంత్ ఎంతైనా ఉండనివ్వండి, వాట్ ఎవర్ ద లెంత్ ఇట్ మే బి, వాట్ ఎవర్ ద డైరెక్షన్, టర్నింగ్ కొట్టినా కూడా వాట్ ఎవర్ ద టర్నింగ్స్ యు ఆర్ హ్యావింగ్, ఇట్ డస్ నాట్ చేంజ్ విత్ ద టైమ్. నెక్స్ట్, నాన్ యూనిఫామ్ ఫ్లో. It is a type of flow in which the velocity at a given time changes with respect to time. It is called as non-uniform flow. Dou v by dou s to t is equal to constant does not equal to 0. Example, flow through a convergent pipeline of varying cross section. So ఇక్కడ పైప్ చూసారు ఎలా ఉంది, పైప్ ఇస్ ఇన్ టేపర్ సెక్షన్. సో ఇక్కడ టేపర్ ఉండొచ్చు, మళ్ళీ బయటికి అటు వేరే ఇంకొంచెం ముందుకు వెళ్ళగానే మళ్ళీ పైకి ఉండొచ్చు, మళ్ళీ కిందకు ఉండొచ్చు. సో whenever the pipe is a convergent pipeline, thereby the water is flowing. This is nothing but the non-uniform flow. Steadiness refers to no change with the time and uniformity refers to no change with the space. Steadyగా అంటే యూనిఫామ్గా వెళ్తున్న దానికి there is no change with respect to time, and uniformity refers to no change with respect to the space, right? This is uniform, this is non-uniform flow. Next, laminar and turbulent flows. So this is the third category. The laminar flow means it is a type of flow where in which the various fluid particles move in a layer, right? This type of flow, the type of flow where the fluid particles move in layers or laminae with one layer of fluid sliding smoothly over an adjacent layer is called laminar. ఇప్పుడు లామినేట్స్ అంటాం. లామినేట్స్ అనే వర్డ్ ఎక్కడ వచ్చింది? లామినేట్స్ మీన్స్ యూ కెన్ సీ ఇన్ ఏ హార్డ్వేర్, యువర్ కార్పెంటరీ షాప్. లామినేట్స్ అంటే లామినేట్ చెక్కలు ఎలా ఉంటాయి, లేయర్ బై లేయర్ ఉంటుంది. ఇఫ్ యు సీ ద wood types, you are having various types, wood, laminates. Like this, you are having various types of wood. So if you see the cross section of a wood, bread slices laga undanukondi, that is simple nothing but laminar. So if laminar flow ela jarugutundi, where the fluid particles ela veltunnayi, moves in a layer by layer, layer after layer, sliding each other smoothly over an adjacent layer, is nothing but laminar flow. This type of flow is also called as streamline flow or viscous flow. ఎందుకంటే స్లైడింగ్ అవుతున్నాయి కదా, స్లైడింగ్ అవుతున్నప్పుడు we are calling them as viscous flow or streamline flow. See here the laminar flow. బట్ ఇక్కడ ఇందాక ఫిగర్ లో యూనిఫామ్ ఫ్లో, లామినార్ ఫ్లో ఒకేలాగా ఉన్నాయన్నారు. yes obviously, but the flow it should be uniform. The flow should be uniform. So the flow of a straight line at constant diameter, దీనికి diameter constant గా ఉంది, బట్ ఇక్కడ కాన్స్టెంట్ గా ఉండాల్సిన అవసరం లేదు, right? That's why the laminar flow is a type of flow where the fluid particles move layer by layer, sliding each other smoothly. Adjacent over layer is called as laminar flow. You see the laminar flow example: flow through a capillary tube, flow of blood in veins and arteries, So మన హ్యూమన్ బాడీలో బ్లడ్ అనేది దేనిలోంచి వెళ్తుంది? వెయిన్స్ లోపల నుంచి, ఆర్టరీస్ లోంచి వెళ్తుంది. సో ద ఫ్లో ఆఫ్ బ్లడ్ కూడా మనకి ప్రెషర్, వెలాసిటీ ఇవన్నీ చేంజ్ అవుతుంది వెన్ ఎవర్ యూఆర్ డూయింగ్ ద యాక్షన్. మనం పెరుగెడుతున్నాం అనుకోండి, దట్ ఈస్ వన్ టైప్ ఆఫ్ లోపల బ్లడ్ అనేది ఒక టైప్ ఆఫ్ వెలాసిటీతో వెళ్తుంది. కాన్స్టెంట్ ఒక చోట కూర్చున్నామంటే కాన్స్టెంట్ గా ఒక చోట నుంచి ఒక చోటకి వెళ్తుంటుంది. సో ద లామినార్ ఫ్లో ఇస్ ఎగ్జాంపుల్ ఫర్ దిస్ టైప్ ఆఫ్ అప్లికేషన్. నెక్స్ట్, turbulent. It is a type of flow in which the fluid particles move in a zigzag way, is called turbulent flow. Example: fluid in natural streams, rivers, canals, etc., artificial channels, water supply pipes. Student, the zigzag way, going in a zigzag way, and you can have any changes. So ఎప్పుడన్నా మీరు కెనాల్స్ ఓపెన్ చేశారనుకోండి, గుంటూరు కెనాల్ డిస్ట్రిక్ట్స్ లో, you can see the water canals. So whenever the water is flowing, ఎక్కడన్నా అబ్స్ట్రక్షన్స్ ఉన్నాయనుకోండి ల్యాండ్ కింద, ఆటోమేటికలీ ద ఫ్లూయిడ్ టేక్స్ సమ్ టర్బులెంట్ వేవ్. మీరు చూస్తూ ఉంటారు, ఎప్పుడన్నా మీరు రోడ్డు పక్కన నుంచి ఉంటే గమనిస్తే, వన్ ఆఫ్ ద వాటర్ ఇస్ ఫ్లోయింగ్ విత్ హై వెలాసిటీ, ద వాటర్ కొన్నిసార్లు స్ట్రైట్ గా వెళ్ళిపోతుంది, కొన్నిసార్లు అబ్స్ట్రక్షన్స్ వచ్చి అక్కడక్కడే తిరిగి మళ్ళీ వెళ్తుంది. దట్ ఈస్ నథింగ్ బట్ టర్బులెంట్ ఫ్లో. ఓకేనా? రైట్. Reynolds number ఈ తర్వాత డిస్కస్ చేసుకుందాం. Reynolds number I will say separately in how it is derived. Reynolds number. Next one, compressible and incompressible flows. Compressible flow and incompressible flow. Here it is a type of flow in which the density of a fluid, density symbol, there is a density of a symbol, density symbol ante idi rho, changes from point to point. The density of fluid is not constant, ante kada. So density changes avutundante it is not constant. That is nothing but compressible fluid flow. Mathematically compressible avutundi kabatti rho is not constant. Next example, flow of gases through orifices and nozzles. So flow of gas through orifice అనుకోండి, if you say an example, flow of gas through orifice, వెల్డింగ్ జరుగుతుంది, ఆక్సీ అసిటైలిన్ వెల్డింగ్, గ్యాస్ వెల్డింగ్ బయట జరుగుతుంది అనుకుందాం. సో గ్యాస్ వెల్డింగ్ జరిగేటప్పుడు లోపల నుంచి ఏమొస్తుంది? ఆక్సిజన్ ప్లస్ అసిటైలిన్ కలిసి ఒక పైప్ లో నుంచి, వెల్డర్ చేతిలో నుంచి, నాజిల్ లోంచి బయటకు వస్తుంది. దట్ ఫ్లో ఆఫ్ గ్యాస్ ఇస్ నథింగ్ బట్ కంప్రెసిబుల్ ఫ్లో. అక్కడ ఏం జరుగుతుంది? we don't know the density of a fluid changes from point to point. ఎందుకంటే వెల్డర్ కింద చేతి కింద కొన్ని నాబ్స్ ఉంటాయి, వెల్డింగ్ టార్చ్ దగ్గర. బ్లూ కలర్ ఈజ్ ఫర్ ఆక్సిజన్, రెడ్ కలర్ ఈజ్ ఫర్ అసిటైలిన్. ఈ రెండు కాన్స్టెంట్ గా తిప్పడానికి ట్రై చేస్తున్నప్పుడు the velocity of a flow of gas will not be constant. That is nothing but an example of compressible flow. Next, incompressible flow. It is a type of flow in which the density of a fluid is constant for the fluid flow. Ante compressible lo not constant, incompressible lo constant. Simple ga appudu rho is equals to constant. Examples enti? For all practical purposes, liquids can be regarded as compressible flows. So ikkada manamu gases use chestunnam kabatti, oil gases, it is not constant, but the liquids are all constant. Next, rotational and irrotational flows. Rotational and irrotational flows. A flow is said to be rotational if the fluid particles, while flowing along the streamlines, also rotate about their own axis. Flow near the solid boundaries is rotational. So if the flow boundary streamline undanukondi, so it's going indak మనం చెప్పుకున్న streamline undanukunnam, right? So whenever the water is going in a straight fashion, at some places depends upon the velocities, they will take some rotational forces and they will move. Flow near the solid boundaries is flow near the solid boundary. Solid boundary the flow near the solid boundaries is nothing but the rotational flows. Example, motion of liquid in a rotating tank. Motion of liquid in a rotating tank. Rotating tank ekkada chudochu. If you see your foot miser or your concrete mixer లారీస్ వెళ్తుంటాయి కదా, వెనకాల పెద్ద ట్యాంక్లు వేసుకొని వెళ్తుంటాయి, తిరుగుతూ ఉంటుంది. వెన్ ఎవర్ యూఆర్ గోయింగ్ ఫర్ స్లాబ్ కన్స్ట్రక్షన్, లోపల మీరు కంకర, గ్రావెల్, ద సిమెంట్, ద వాటర్, శాండ్ వేసి తిప్పుతుంటారు. దెన్ ద లిక్విడ్ అక్కడ ఏం జరుగుతుంది, రొటేషనల్ టైప్ ఆఫ్ ఫ్లో జరుగుతుంది. దట్ ఈస్ ఎగ్జాంపుల్ ఆఫ్ రొటేషనల్ ఫ్లో. నెక్స్ట్, irrotational flow. A flow is said to be irrotational if the fluid particles, while flowing along the streamlines, does not rotate about their own axis. Flow outside the boundary layer is generally considered as అది rotational అయితే, this is does not consider it is irrotational flow. Okay, so if you see the example of this rotational irrotational, you can see like this. So చూడండి, 6.A rotational flow. You see the x-axis, y-axis and z-axis. Fluid motion is like this, irrotational. So ఆ ప్రాసెస్ లో ఫ్లూయిడ్ పార్టికల్ ఇలానే ఉంది, XYZ ఇలానే ఉంది, ఇక్కడ కూడా XYZ ఇలానే ఉంది. సో వెన్ ఎవర్ ద ఫ్లూయిడ్ మోషన్ ఈస్ రొటేషనల్ ఫ్లో, సీ హియర్ ద XYZ డైరెక్షన్స్ లో ఫ్లూయిడ్ పార్టికల్ ఇలా వెళ్ళినప్పుడు, రొటేషన్ జరిగినప్పుడు ఏం జరిగింది, దేర్ ఎడ్జెస్ ఆర్ automatically change. This is nothing but the irrotational. Laminar flow, see the laminar flow, the velocity, the laminar flow here, the velocity is constant. Laminarly it is layer by layer. See, this one layer, this one layer, this one layer, this one. So you are having 1, 2, 3, 4, 5 layers of the liquid movement. If you see, you can next one dimensional, two dimensional. This is this case. Okay, but anyways, the time is up now. I have the other class. I have the third year civil. The time is less than 1 minute. Today, take a screenshot. So this video will be uploaded in the link, and I'll forward the YouTube link. Just watch the links and share to other friends. Thank you for listening patiently. Other students kuda ramman cheppandi. Only Ramesh, Falguna